Today's lesson is on graphing periodic functions. A periodic function is one that repeats itself exactly. There's no change in level or length in a cycle. An example of a periodic function in nature is the number of hours of daylight in a year. Each year in the winter we experience the shortest day of the year, the winter solstice. Then, as the Earth tilts on its axis, we gradually have more hours of daylight until summer, the summer solstice. That's the day with the most sunlight during the day. Then there are 2 times in the year when the hours of darkness are approximately equal to the hours of daylight, which we call the vernal and autumnal equinoxes. In mathematics, the trigonometric functions are periodic. Each time you complete one revolution, the values repeat themselves for sine and cosine. It takes a tangent only a half of a revolution to repeat itself. Today we're going to focus on the sine and cosine graphs. We typically graph sine and cosine using radians because one revolution is 2 pi radians, which is about 6.28 radians, as opposed to 360 degrees. We wouldn't want to have to graph all the way from 0 to 360 when we can only graph from 0 to 2 pi. Let's take a look at the unit circle and the sine function. Remember that the sine function is the y values only. So we're looking at the 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1, and as we would continue around the unit circle. As we move around the circle, watch the movement of my pen. It goes up until I reach pi over 2, continues and moves down until I reach pi units, continues in a downward motion until I reach 3 pi over 2, and then goes back up at the end to 0. So let's take a look at what goes on if I were to graph this on the coordinate plane. I start at 0, and each one of these tick marks on my graph counts for 1/4 of the circle, and this is 1. So at the end of 1/4 of the circle, I've moved up to 1. By the time I finished half the circle, I moved down to 0 again. At 3/4 of the circle, I'm down at -1. And by the time I finish the circle, I'm back up at 0. Looks a lot like the schematic that's on the front of your calculator things. Now look what happens if I went backwards. I go down for 1/4 of a circle. Then I go up for 1/4 of a circle and I'm back at 0. Then I go up for another 1/4 of a circle and I'm up at +1. And then I go down for 1/4 of a circle and I'm back down at 0. So you can see how the cycle keeps repeating itself. If I were to continue drawing on the left, it would go down and then curve. On the right, it would go up and then curve. You can see that I've made the graph as a smooth curve, not in jagged lines. Part of your homework, I would like for you to explain why this happens. Now there are some properties that go along with the sine that we should all know. First property is that the domain of the sine is all real numbers. We can take the sine of any angle as we go around the circle. Remember that the highest it can go is +1 and the lowest it can go is -1. So the range of the sine is -1 is less than or equal to y, which is less than or equal to +1. How long does it take to complete one revolution? Remember our conversion when we were converting degrees to radians. 2 pi radians is 1 rotation or 1 revolution. And since we're dividing that up into fourths, 1/4 of 2 pi is pi over 2. So we're actually counting by pi over 2's. 0, pi over 2, 2 pi over 2, which you notice we just reduced to pi, 3 pi over 2, and then 4 pi over 2, which would reduce to 2 pi. So on our graph, if we were to label our increments, this would be pi over 2, pi, 3 pi over 2, and 2 pi. The highest point reached was 1. The lowest point reached was -1. And our starting point for the sine curve happened to be at 0, 0. Now we're going to look at the cosine function. And remember, when we're looking at the cosine function, the x value is the only number that we're looking at. So let's look at our x values this time instead of our y values. We have 1, we have square root of 3 over 2, square root of 2 over 2, 1/2, and 0. And then as we would continue around the circle, we would hit the other ones. So let's think of this now in terms of movement left and right. As I start my circle, I'm moving in which direction? I know I'm moving up, but we don't want to look at that. We're wanting to look left and right. I'm actually going to the left, and I started at +1, and I moved to the left all the way until I reached -1. And now as I continue around the circle, I am going to move back to +1. So what's happening with the cosine curve is it's just a little bit different. This time I'm going to start at +1. By the time I've reached 1/4 of the circle, my x values have moved far enough to the left that I'm now down at 0. By the time I finish half the circle, I'm all the way down to -1. By the time I reach 3/4 of the circle, I'm back to 0. And by the time I get my full revolution in, I'm back up to 1. So I moved left. This is actually showing movement left because my x values were decreasing. Left, right, right. I can take that and fill in the other side of my graph exactly the same way. Again, some properties here. Notice that the highest value I reach is 1. In other words, the farthest to the right on the circle I could go was 1. The farthest to the left on the circle I could go was -1. I can find the cosine for any number, so my domain is all real numbers. My range was -1 was less than y was less than 1, which means in this case we're considering y to be the cosine of x. All of my cosine values were between -1 and 1. My period is still 2 pi because it takes that long to get one revolution in. I still am dividing the circle up into 4 equal parts, so my divisions are pi over 4s, and my starting point is different this time. Instead of 1, 0, or instead of 0, 0, I start at 0, 1. So my cosine function starts at the top of my graph. You're actually going to be asked to graph these functions on different domains or different intervals. For us, this is actually going to be a calculator function. We're going to do it as a calculator exercise, so you need to know how to use your calculator to make this work. The first thing you need to do is you need to take your calculator and you need to set it in radian mode. So you're going to push the mode button on your calculator and change it to radian. So let's get started. First we push mode, we highlight radians, press enter, and we're halfway there. The next thing we need to do is we need to realize our range. Our y values only go from -1 to 1, but we usually like to see a little above and a little below. So let's, oh wait a minute. Let's back that truck up. Let's start with our x values. Our period is 0 to 2 pi, but we like to see left and right. So let's go -2 pi. So we'll go to window, and we'll change our x min to -2 pi. We'll change our x max to +2 pi. And now for our divisions, this is what we're counting by on our graphs. And remember, before we were counting by pi over 2's. So we're going to change our x scale to pi over 2. Now let's think about our y values. We really don't need to go up as high as 10 or as low as -10. As low as -3 should be enough. We'll be able to see everything well. And as high as +3 should be enough. And we can still count by 1's. Now let's go back and let's put a graph in and see what it looks like. This time we're going to graph the equation y equals the cosine of x, and we're going to have a domain of negative 7 pi is less than or equal to theta, which is our x, which is less than or equal to negative 4 pi. So I only want to look at a specific portion of the graph. Let's look at cosine of x first. Let's type in y equals cosine of x. Always close that parenthesis, such a good idea. And then hit graph. And now let's look at that graph. Does that look like what we just did when we graphed it on our own? Can you see that repeating pattern of the cycles, the waves? Starts at 0, 1 and goes down as low as negative 1. All right, now let's change this problem and let's look at it in terms of what if we weren't interested in the part between negative 2 pi and pi? What if we're interested in the part of the graph between negative 7 pi and negative 4 pi? Well, here's what we're going to do. We're going to go back to our window, and we're just going to change our x-min and our x-max to match. So we'll type in negative 7 pi for our x-min. We'll type in negative 4 pi for our x-max. And we're still going to use the same x scale. Now let's see what it looks like. Notice we can't see the y-axis anymore. It looks a little bit different because we're not looking at the entire function. At this point, what we would do is we would take that and copy that onto our graph. So let's go ahead and take that now and copy it onto the graph on the next page in your notes. You'll notice this graph looks a lot like a number line right now. We don't know quite where everything is, so let's go ahead and start labeling. I'm going to start at negative 7 pi because I knew that was the first number on the interval I was interested in. And my next number would be negative 6.5 pi, but we usually write these as improper fractions, so that would be negative 13 pi over 2. Then negative 6 pi, and we're going to continue to count down by pi over 2. So negative 11 pi over 2, negative 10 pi over 2, which is negative 5 pi, negative 9 pi over 2, and then negative 8 pi over 2, which is negative 4 pi. This is as far as I needed to go, so I'm going to go ahead and put a little break in the graph to show that there was a break there. And I'm going to go ahead and add a y-axis because I like to see where I am, and this will give me some idea of setting my boundaries at negative 1 and positive 1. The graph on our calculator started at the bottom end. It started at negative 1, and at the first division was back at 0, then up to the top, then back to the middle, down to the bottom, back to the middle, and back up to the top. So that's what this section of the graph actually looked like. Looked kind of like that. Now, what the problem would have looked like in your text would have been this. It would have said y equals cosine of x, and then next to it, it would have given you the interval that you needed to graph it on. It would have said negative 7 pi is less than or equal to x, which is less than or equal to negative 4 pi. This will conclude our podcast for today.